Well, now that we've defined what the average rate of change of a function is, and recall that it is the secant line that goes through 2 points on a curve through the endpoints of the interval, and it doesn't represent the instantaneous rate of change of the function, but rather the average slope of the function through an interval. Well, now that we've defined all of that, we can actually start to compute the average rate of change of a function over an interval. So we've got this example, and we have the function f of x is equal to x squared plus x plus 1, and the interval is 2, 4. So let's begin by drawing a graph. Let me redraw that. Okay. And I'm not even going to really worry about exactly what this shape of the graph looks like. Of course, we could figure it out by plotting a couple of points, but I'm just going to draw some ideal curve here for our scenario. So I'll draw that. And we have the point 2, so 1, 2, and then 3, 4. So we've got 2 and 4, and this is the x-axis and the y-axis. And what we're going to do is we're going to say, okay, well, if this is 2, then this point will be f of 2, so f of 2, and this point up here will be f of 4, f of 4. So now we will draw the secant line through these 2 points. So these 2 points converge right here. This is the point 2, comma, f of 2, and then this point is the point, well, that's 4, comma, f of 4. And the secant line is going to be the line that goes through both of those points, and I can zoom in a little bit. It's the line that goes through both of those points. It isn't necessarily tangent to the curve, or rather it doesn't represent the instantaneous slope of the curve at any point, but it does represent the average slope through the point, through the interval 2, 4. Well, now if we want to compute it, we can recall that the formula for doing this is the change in y over the change in x. And in this case, this would be, well, our dependent variable y is written as f, because it's a function f of x. So this is equal to the change in f over the change in x, which is equal to f of b, so f of b minus f of a all over b minus a. Well, our 4 is our b, because that's the last point in our interval, so this is b. And our 2 is our a, that is the beginning point of our interval. So this will be f of 4 minus f of 2, and then all over, well, it's going to be b minus a, which is 4 minus 2. If we plug these into the function, then we get, well, we'll get 4 squared plus 4 plus 1, and then this will be minus, that'll be 2 squared plus 2 plus 1, and then all of this over 2, because 4 minus 2 is 2. Well, 4 squared is 16, so 16, and then plus 4 plus 1, well, 16 plus 4 is 20, and then 20 plus 1 is 21, so 21 minus, well, 2 squared is 4, so that'll be 4, and then 4 plus 2 is 6, plus 1 is 7, so 21 minus 7, all over 2 is equal to 14 over 2, which is equal to 7. Well, what we just found was the average slope through that interval 2, 4. And it's important to note that although we have a positive slope, which means that our function is climbing between the interval, or over the interval 2, 4, it doesn't necessarily mean that our function is always going to be positive during or over that interval. In other words, if we have an average slope that's positive, it doesn't mean that the slope is always positive over that interval. And on the other hand, if we have a negative average slope, it doesn't mean that our slope is going to always be negative over that interval. And the third option is, well, if our average slope is 0, it still doesn't mean that our slope over the entire interval is going to always be 0. And I'll draw a couple of cases that will describe that a little bit better. So let's say that and I'll draw a similar function to what we had last time. So if we define some interval, if we defined some interval that was like this, and we said, okay, well, when we find the slope of this secant line, well, obviously the slope is greater than 0. It's positive because this blue line, it's climbing. It has a positive slope. However, if we look at the function, if we look at this function right here, well, the yellow line is obviously it's going down. And let me draw a negative or a downward arrow. It's going down right there. And then about at this point right here is when it starts to climb. So it starts to go up. So it goes from a negative slope to a 0 slope to a positive slope. And overall, the average slope over that entire interval is positive, which means that it's climbing at a greater rate, or it's climbing more than it's falling. So that is how we compute the average range or average rate of change of a function over in a given interval. I hope you found this video helpful. If you have any questions, please leave a comment below. Please subscribe to help the channel, and I'll see you in the next video.